Hey, what's up guys, this is Vector99 back with another stream. This is a fourth stream, I believe, in this series where we are making a game engine from scratch using C++ and OpenGL. So let me check if it is a fourth stream or not. I think it's the fifth stream. I forgot the count. Oh my god. Yeah, so it's the fifth stream, my bad. I'll change it a little quick. I'll change the name. Okay, stream number 5th. Alright, cool. Welcome. So last episode, since the last stream, what we had this thing here. We had a triangle, and we had this triangle since quite some episodes, but we made a matrix class. Okay, it took us some time. It was probably the longest stream that I had done till now, but we successfully made a matrix class. Okay, now we are having this boring white triangle for quite some episodes, and I believe from the last 3 episodes we still have this. So in this episode I want to change this. Okay, so we're finally going to be, hopefully we're going to be change this triangle into something colorful or something that moves or something like that. We'll see what we can get. Alright, and how we're going to do it is by using shaders. So shaders are very much important in graphics programming. Just quickly, if you don't know what a shader is, well, shader is a program, just like a .exe program. Shader is a program that runs on the GPU. Okay, so usually the .exe programs that we make from C++ and other programming language, they run on the CPU. But shaders they're smaller programs that run on the GPU, and they're actually extremely important because right now we don't have any shaders yet, or at least it seems that way. We don't have any shaders, but in reality we actually have a default shader. OpenGL gives us a default shader which we can use to just see some stuff on the screen. Right? If we didn't have any if we didn't have any shaders at all, we wouldn't even see this white triangle. Okay, if we didn't have any shaders, then we won't even see this white triangle. So shaders are extremely important. Shaders work with buffers. So buffers are a way to send the data to our graphics hardware. So buffers sends the data, and shaders are what actually use the data to show stuff on the screen. Okay, so buffers and shaders work hand in hand. They're like two sides of the same coin. They're extremely important. And yeah, this video, in the previous videos we tackled buffers. So we wrote all our buffers. We send it the data. This video we're going to be working on shaders finally. All right, cool. Let's get into it. Let's see again what we had. So the plan for this stream is also going to be pretty long, I guess. We're gonna have, let's change the triangle to have some solid color. Okay, we're gonna have some color. So yeah, let's get into shaders. If you guys remember, I believe I did this on the window class, the first stream ever. I made a folder called resources, and we had 2 folders inside it called shaders and textures. Okay, cool. So under shaders is where we're actually going to be keeping our shaded codes. By the way, there's two types of shaders. One is Vertex Shader, another one is a Fragment Shader. I'll just explain it as I go, because if I explain all the things here, it will probably be extremely long, so it won't probably be that much exciting as well. So this is where we're going to be putting our shaders code, our shader code, and the actual shader, the CPP and H file that's going to compile our shader, we'll put it under the graphics folder. Okay, so under here we'll add a new item. I'll call it, let me maintain my chair as well. My chair is a heavy chair. Okay, cool. I'll add a header file, call it shader.h, and I messed it up. I wrote shader.h. I'll add another one. I'll call it something like shader.cpp, of course. Shader.cpp. Okay, cool. So in the h file, we so basically what do we need to write a shader? Well, usually we write shaders in text files. Yes, that's what we use. But how do we actually give OpenGL the shader code from the text file? Okay, well, basically one way is we read the text file. Okay, we read the text file using a file handling in OpenGL. then we store our contents of the text file, our actual shader code, into a string, and then we give that string to OpenGL, which means that first we need to read a text file, so we need to make a loader, a text loader thing. Okay, so the way we do it is we'll just we'll write the write the loader function as well here. Okay, so we'll do everything in shader.h. Right, so class shader. We'll have a couple of private members. I'll probably need to include IOStream, and I'll have to include string as well. And for the input, I'll have to include ifstream, I believe. Input file stream. I forgot what the name was. iStream, I guess. Stream. Output stream. Input stream. iStream. Yeah, it's iStream. Alright. Cool. That's it. I'll have a couple of private variables. I'll of course have the shader ID. So it'll be unsigned int p shader ID. I'll have a string for the shader code, so Vertex Shader code and Fragment Shader code, and that's pretty much it. I'll probably just keep it. I'll just probably keep a track of the file path as well. So std string VS Code path fragment code path, and that's it. So public, we'll have constructor shader. I have another one called a destructor, and I can't type for some reason. I need to bring my chair back. Damn you, chair. This is a very heavy chair. Okay, and we'll have a couple of functions. We'll have void bind to actually bind the shader to use the shader. So call it. Why did I type use there? So I'll have another one called unbind. It's going to be constant as well, because all they're going to do is just bind the shaders. They're not going to change any member variables at all. Okay, this is our basic shader class. Now we'll also have another called set the uniform values, stuff like those. I'll put this one as well. Yeah, that's it. Let's start writing the implementation. Right, so include in shader.cpp, include shader.h our constructor, our destructor, our bind function, and our unbind function. Also we need the const. Alright, cool. Let's start actually writing the shader code. Now I will of course have to include glue pound include gl slash glue.h. Okay, so let's just start coding the actual method that's gonna load our files. Okay, so I'll just create this so under these arrays say shaders, I'll create two text files. I'll call one Vertex Shader .glsl, and I'll add another one called Fragment Shader. And by the way, you can name these anything. You don't need the .glsl. You can call it like dot whatever you want. You can call anything. I'm just writing GLSL because it just makes sense, because we write all our shader codes in a separate programming language called GLSL, which is a graphics, the OpenGL shading language. So yeah, I'm just writing this. You can name your shader files anything you want, basically. That's what I'm trying to say. Okay, all right. Fragment shader, vertex shader. Okay, so we basically need a way to load this file into a text file. So we basically need a way to load these two text files, because that's what basically they are. They're just text files. We need a way to load these text files into a string. Okay. And hopefully into this code, so Vertex Shader code and Fragment Shader code. So how do we do it? So we use the iStream. We included this so that we can use so there's a function called std ifstream, I believe. Yep. So the if stream. So this is what we're going to be using to load the files. Now I know that this is not the best way to load files, because the C++ file handling functions are a bit slower than the C functions. However, since probably most of the time we're going to be loading this shader once and using it for most of the program, it's not going to make much of a difference, I guess. So yeah, we're just going to be using the standard C++ file loading system, and that's what we're going to be using. Alright, so I'll have to make another function. I'll have to call it void load shader const. Okay, I'll implement the function real quick. Void load shader. It's not gonna be const, of course, so because we want to modify these functions right here. And the shader constructor is actually going to take some parameters. You're going to take in a std string Vertex Shader path and a std string Fragment Shader path, and we'll might as well take it as a constructors. Okay, cool. Let me copy this, paste it over here, and that's basically it. Alright, load shader is going to take in some things. Going to take a cons actually string reference again, of course, by a Fragment Shader shader path. Copy this, I'll paste it here, and this is probably it would probably be wise to put it up here, because it's the first thing that we're doing after the constructor. Okay, cool. Okay, load shader. So basically we're going to be using fstream, like I said already, and it's going to give us the shader path. And let's just kind of like initialize everything here. So p shader id was set to 0 by default. VS Code. This code will set it to an empty string. Fragment Shader code will set it to empty string. VS Code path will set it to empty string. Fragment Shader path will set it to Fragment Shader code path, set it to an empty string. Alright, awesome. Here, actually, we have this path here, so I guess we don't need to set it to an empty string. Vertex Shader code path, we'll set it to shader path. Fragment Shader code path. Alright, so load the shader. Yeah, we'll load the shader. So Vertex Shader code is equals to load the shader. Let's load the shader code. Shader path. We'll give the Vertex Shader path. Copy this. We'll do for the Fragment Shader code, Fragment Shader path. Let's give us an error for some reason. Load shader. Of course, load shader needs to return a std string. Good. Return as a string. Now it works. Okay. So now we have loaded, and of course we have to write the function here first. So okay. So we load the shaders. That's the first thing that we do. Okay. Let's write the function. Let's write the actual loader function. I'll make an object of the if stream. So if stream object. I'll call it stream, and this takes in a constructor for the path that we're trying to load. So shader path, and it's giving me an error. Incomplete type is not allowed. Local variable is initialized. All right. Why? If stream. What does it take? Takes in a I guess it doesn't take anything. Input file stream. Does it take a C string? If it doesn't take a C string, it should take a standard C++ string. We'll see why this is not working. So if stream. Case iStream, is it iStream? It's an iStream. It's input file stream. IF stream C++. Guess we have to include the file IF. Should be IF stream, isn't it? IF stream in C++ to load files. Okay, F stream. Okay, oh, it's file stream. My bad. Oh shit! I just dropped my thing. Okay, so it's as input file. Okay, so this is file stream, not I stream. Okay, cool. It works nice. I was just looking at it from this website, right? So input out C files. Supposed to be F stream here. Supposed to be F stream. Okay, awesome. By the way, like I said, it's very wise to check the documentation. This C++.com is the best documentation for C++ that's out there. For OpenGL, there's a website called docs.zl. This is the best one for OpenGL. Like there's a lot of OpenGL functions. Like for example, the GL bind buffer, GL3. We can see how the function how the function works and how we can use it. So yeah, so these two are the best documentations for C++ and OpenGL. That's what I'm trying to stress. Okay, cool. So input file stream. So we have loaded the stream. So the way C++ loads a text file is it kind of stores it in a line by line basis. So we'll need to make another string for line. So line, we'll call this line. So while std get line. So while we are still getting the line from the stream and we'll store it in the line, we want to keep the code running. Okay. So while we have line available, we want to store it into a string. Call it std string shader code. We'll do shader code plus equals line, and I want to plus a null terminator character here. Okay, cool. That's it. Plus line 1 is hopefully read our code. And what you do with this, we're going to return the shader code. Okay, awesome. That should be it to load the shader. If we just try to print one, so actually see our Vertex Shader code, and we can actually check it. I'll include shader.h here. So window graphics. I will include graphics shader.h, and down here I'll set up my shader. So I don't need the okay, I'll just keep it here. Let me just show here shaders. Let's make a new shader file. Shader. It wants the location of the path, so let's call it res shader vertex shader.glsl. Copy this, paste it here. Of course, the colon is necessary. And we'll call it fragment shader.glsl, and we'll do shader. So just for testing, so we'll just test if it works or not. It calls the constructor, it loads the shader from Fragment Shader, Vertex Shader. Let's do something right here. Test loading fragment. I'll copy this. I'll do from Vertex Shader, test loading vertex. So yeah. Let's copy this. Fragment Shader code, run the code. Hopefully we see our 2 lines, and we don't because it's an unresolved external symbol. This call should, oh my god, what the hell is this, man? What is this? What even is this? Okay, so we get one error. Load shader. I think I cannot find our file. Oh yeah, we forgot the class type here. Awesome. Let's try it now, and hopefully we get our shader code. We don't. We don't. So something's wrong here. Okay, Vertex Shader code. So load the shader. Vertex Shader path plus equals line. Vertex Shader path. What path do we set here? Right, shader, Vertex Shader GL shell. Vertex. So. Okay, such a DR. I forgot the spelling. I forgot the spelling of shaders. Okay, cool. So test loading vertex, etc. So awesome. So we are actually, yeah, we are loading shaders. Cool. Yeah, that's that. Let's get rid of this. Our loader function is working fine. And I will. If we can find the definition. Yep, we can find the definition. I'll get rid of this now. And that's basically it. So first we load the shaders into strings. Yeah, so now we have successfully loaded the shaders. Now it's time to compile these shaders. Okay, so I'll probably make a separate function again called compile shader. I'll put it over here. It's gonna return an ID, so it's gonna compile and return an ID of the compiled shader. So unsigned int compile shader. It'll take a unsigned int shader type, and it's gonna take the actual source code for the shader. So it's gonna take the shader code basically. We'll do std string by const string shader code. Okay, cool. Copy this, paste it here. So after the load shader, don't forget this. Alright, compile shader. So how are we gonna do this? So after this, after we load, we're gonna call it compile shader. Unsigned int vertex shader ID. We'll do compile shader. Type is gonna be GL vertex shader. It's an inbuilt OpenGL flag. The shader code is gonna be vertex shader code. Copy this for the fragment shader ID GL fragment shader code, and that's it. Fragment shader ID, vertex shader ID. Okay, let's just compile the shader right here. I will just compile it right here. Okay, so how are we gonna do it now? Like I said, there's a documentation for OpenGL. We call it docs.gl. If you have if you forgot something, if you forgot how a function works, you can just search it here. For example, I'll do some of the GL compile shader. So let's just see the process of basically compiling shader. First, we need to provide the shader code to OpenGL, and the code that we use is something on a GL shader source, I believe. Yeah, GL shader source. So this is the code that we use to send this send the code to OpenGL. Okay, GL shader source. So let's just type it here. We'll do compile shader. So GL shader. We'll obviously have to make a shader ID. Yep. Let's make a shader ID. So unsigned int shader ID. Let's make the ID for the shader, and let's give OpenGL the code. All right. So shader type. It has to create a shader ID. Okay, shader ID. Yeah, so shader ID is equals to. First, we have to create the actual shader object. So GL will create shader, taking the type. It's going to be the shader type. which is going to be either the vertex shader or the fragment shader that we specify up here. Okay, awesome. After that, we'll do, so we have successfully created the shader, and then now we'll send the data to the shader object. So the geo shader source, it's going to take the shader that we're sending, so shader ID, and I'll make it small. I need to be consistent with how I name my variables. Shader ID count, so how many shaders are we sending? We're sending one, a pointer to an actual string. So we'll probably have to do something here. So const char shader const char we'll do code, we'll call it shader code dot c string. Okay, this is a bit dodgy. This code is a bit dodgy. You would hope because the c string function is a dangerous function, kind of, if you don't know how to use it. But for us, it's going to be fine. Yeah. So one the pointer, it wants a pointer to a string, so we'll have to set the address. It wants a pointer to a pointer, so we'll send the address of code, and the length is just 0 because we just want it from the beginning. We want the shader code to be sent from the beginning. Okay. Okay. Cool. Now we'll do geo compile. Compile shader, I believe. Yeah, geo compile shader. The shader ID is this. Okay, so we send the code to the shader code to the shader ID, to our shader object, and then we just compile it. Okay, cool. And here we'll just return the compiled ID of the shader. So shader ID. Awesome. So that's pretty much it. That's how we actually compile the shader. Now we get these two shaders here. Let's just link it. Basically, that's how we compile the shader. So we compile, we create an ID, we set the code, we send the ID of the shader, and we compile it. The ID. Okay. So vertex shader, fragment shader, that's how we do it basically. Once you have compiled, so the shaders work quite like the OpenGL, not OpenGL, the C++ file. So once you compile, so for example, so what happens when you compile a C++ file? You get an intermediate.obj object. And after that, after the compilation process, the linker, the C++ linker, actually links those obj object, and finally you get an exe object, .exe file, .executable file. So to make that, so it's the same process in OpenGL as well. So we have compiled our shaders. Now it's time to link them. Okay, and we link them to a program. So we link two shaders into a program, so we'll have to create the program here. Now we have this shader ID thing here. We'll make this our program. So p underscore shader ID equals to geo create program. It's not going to take anything. It's just going to create a program and return us the ID of the program. Now here's what we need to do. So geo attach shader. So shader, it runs a program, so we'll attach p underscore shader ID to the actual shader. So vertex shader ID. Then we'll attach the fragment shader. So fragment shader ID. That's that. And after we have attached it, now it's time to link it. So geo link program will link the p underscore shader ID. And I'm not consistent with my writing here. I should be I should have a p underscore here, but I'll do it. So after linked it, we need to validate it. So geo validate program will validate the p underscore shader ID. Okay. That's it. I need to be consistent with my API, with my variables. So I'll just do a quick find and replace. I'll replace in files, current document. I'll find VS Code, replace it with p underscore VS Code. Replace all, two occurrences, fragment shader code. Fragment shader code, p underscore fragment shader code, replace all. Okay, cool. Yeah, that's basically it. Okay, let's shader CPP, and now of course I'll have to do everything here as well. Vertex shader code. Let me see. Do I have anything? Nope, I don't. Okay, so I can do it. Okay, Vertex Shader code, I'll replace it with pure Vertex Shader code, replace all. We'll also do Fragment Shader code, I'll replace it with Fragment Shader code, replace all. Okay, cool. That's pretty much it. No errors found, P-Shader ID, P-Vertex Shader code, everything looks to be normal. Alright, let me just check it once more if it's working or not. So, yep, it's working well. Okay, cool. That's basically it. So we have done it. We have linked the program. Now we can actually delete these intermediate objects, which you should be doing. So geo delete shaders, geo delete shader. We'll have to do the Vertex Shader ID because we have already linked them. We'll do delete the Fragment Shader ID. Fragment Shader ID. Okay, cool. That's pretty much it. Build the program, we'll create the shader ID, we'll link the program to a pre-shader ID, and yeah, that's it. So I'll just go to the destructor here. I will delete program. I'll delete the p_shader ID, shader program. I should call it shader program ID, but I don't want to name my variable so long. I'll just shader ID. So bind. Okay, bind. So if you want to bind the shader, we use the code known as geo use program. Use program. We bind it. We use the program. We bind the program that we're going to use. So it's p_shader ID. If you want to unbind it, we just bind 0. That's it. Okay, cool. Easy as that. That's pretty much it. That's our basic shader class. So we should be able to write some okay shader code. Yeah, we can just check it right now. Yeah, we can just check it. Let's go to the shader.h, fragment shader. Let's try to print the shaders first. So I'll make this public for now. Okay. So I'll write something here. So I'll write some code. Take shader. Also write some more code. Main.cpp. I'll do shader dot p_vertex shader code. Let me see if it works or not. Yep, it works. It works nice. Let's do the fragment shader code. So the fragment shader code, and it does. Okay, cool. So okay, our shaders are working fine. At least the file handling stuff, they're working fine. All right, so let's get into doing this. So let's just check our shader. So I'll just write a basic shader code here. So version 330 core. I'll write a basic shader. Void main. Taking from the layout. Location equals 0. In vec2 position. We'll do geo position is equal to a vector. It needs to be a vector 4. 0 on the z, 1 for the homogeneous coordinate. Pretty much it. Let's go to our fragment shader. Core void main. It's gonna our fragment shader is gonna output a color. So out vec3 color. Should be a vec4. So we do color. We'll just hard code it to be a simple color. So we'll do. Let's make it yellow. So red, green, blue 0, alpha 1. Awesome. I'll vec for color. That looks vec2 position. Position. Set the position. GL position. That's pretty much it. So let's just go. Shader dot. So we have sent the code down. It's gonna get the shader ID. It's gonna create the program. It's gonna do everything by itself. We don't need to tell anything. And I'll let program. Okay, so we'll do geo. We can do GL use program here, but we don't have to. All right, make it private. We don't want things to be public. So let's do shader dot bind. Okay, so this is gonna call the GL use program to shader ID. Okay, hopefully now we see something different on the screen. Hopefully we'll see something different, and we do. Isn't that cool? We don't see the boring white triangle anymore. We see the bright or yellow triangle. This is cool. This is cool. Cool. Finally, happy to see something else other than that boring white triangle. All right. That's so our shader's working. Our shader's compiling well. That's what we get to know. Everything is working good. But what if we make an error in our shader? So for example, if I forgot this bracket right here, okay, pretty simple error, can happen to almost everyone. Okay, what if I forget this? And now if I run the code, of course we don't get our desired triangle. Okay, and we will be like, what the hell happened? We'll have no idea what the error was, where the error, especially if our shader code was like pretty long. It could be like 100-200 lines of code. If we are writing a big game, we'll have no idea, and we'll have to debug every single line of our shader code to see what's wrong, which is a nightmare. Which is a big nightmare. So how do you fix it? Well, we'll have to manually write. Let me get rid of that back. Okay, cool. So we'll have to manually write a kind of an error handling code for our shaders. Okay, so we'll do it in our compile shader. So we'll check if our shaders are compiled or not. So we'll write the error handling code here. So error handling. Okay, so the way we do this is we actually have to query OpenGL. Okay, so first we have to query OpenGL and ask if the shader compilation is done well or not. Okay, if it worked or not. So we'll have to do it after we compile the shader. Error handling here. So let's just query with OpenGL and ask if our shader compilation went well or not. Okay, the way we do that is we type the following code. So we do GL get shader IV, and we get the shader ID. So shader ID. Then we pass in the parameter name. So it's called GL compile status. So if our comparison worked well or not, and it's a parameter, so we'll have to make an int result, pass in the address result. So what will this do is that OpenGL will put the status of our compilation. It will put it in this result variable, and if the compilation went well, it will put 1, which is true, and if it didn't went well, it will just put 0 here, which is false. So we'll have to check it. So if the result is equals to GL false, which means our compilation didn't went well, which is GL false is basically, you can see, is pound defined to 0. So we can pretty much say if not result, so it is the same as saying if not result. Okay, so if our compilation was unsuccessful, we want to say something. So first we want to display what the actual error message is. Okay, so for that, to display the error message, we'll have to get how long the error message is. So we'll have to make another one. I'll probably make something like int length, just call it length. I'll do GL get shader IV again, our shader ID, I'll call it, so GL info, I think info log length, yeah, GL info log length, so how long the error message is. We'll store the length in the length. Okay, so what this code will do is that it will see how long the error message is, and it will write the length in our length variable that we specify here. Okay, so let's make a buffer of memory that can store the error message. So a char pointer, call it something like error message. We'll assign it to a new char to be a length. We'll do it on the heap of length of the actual length. Of course, we have to delete it. Don't forget to delete it. So delete error message. We'll have to do an array delete because we're specifying an array. Okay. Okay, so if result equals yield false, we'll do this. So let's just print our error message. But before we print, we actually need to like store it. Store the error message in this error message variable here. So the way we do it is we just write this code. So we do GL. I think it was get shader info log. Yeah, GL get shader info log. So the shader is the shader ID. We'll do the buffer size is the size of the actual length, so how much in bytes, and now we want the pointer to the length, and the info log is where do we want to store it. So we do store it into the error message variable that we had just created. Okay, so after that we'll just print the error message. So error message, and what we'll do is before printing this, we'll do if we'll check something. So if shader type is equals to geo vertex shader, print something like here. So vertex this. So we'll do vertex shader error this, and we'll just print this log message here. Else, so if it's not the vertex shader, we'll just do Control C, Control V, we'll do fragment shader. Now in the future, if we decide to like include more shaders into our engine, because there are of course more than just vertex and fragment shaders, there's like geometry shaders, there are tessellation shaders, there are all those kind of shaders. If we ever decide to include them, we'll have to change this a bit. But for now, for 99% of the time, it's just gonna work fine. So I might as well rock with it, you know. Okay, cool. That's basically it. So if it's vertex shader, it'll print vertex shader. Else, if it's a different than vertex shader, which means in this case it can either be vertex. If it's not, it can be fragment. So let's do fragment shader error, and we'll print out the error message to the console. Okay. After we do that, we delete it. We delete the error message, and that's it. Okay, cool. That's basically it. That's how we handle the error in OpenGL. Now, if we can do here, if we check it again, so our vertex shader, we had the yellow triangle, our lovely yellow triangle here. What we'll do is we'll just do something like okay, we'll just our same error. So we missed it. And boom, you can see we get our message from error. So vertex shader error from line 7. So you know line 7, see, it gives you the exact line. It says vector position undeclared identifier and cannot convert to this. So yeah, you can see it says syntax error. So it says that there's something wrong with our syntax, which means that we're missing this bracket, and if we run again, we get no error. Okay, awesome. So that's how we handle shader errors. Just done. Okay, pretty cool. So that's pretty much our shader class, but we're not done yet, of course. We'll still have to set up the uniforms for our shaders, so we'll do it under here. I wrote the set up the uniform values, so we'll just begin shading up the uniforms. Alright, so first we'll just do a void set uniform matrix first. So we'll do we'll do vec. So we'll do vec3 set your uniform vector 3f. We'll take in a char pointer name of the uniform, uni name for the uniform name, and I'll just take in a vector 3. So let's do vec3. It's going to take in a vec3 by reference, of course. Const vec3 reference vec. I'll have to include vector now. Include maths vector 3.h 4 as well. Include matrix as well. So mate4.h. That's pretty much it. So vec3 error, of course, vec3 is undefined because we have this in so it's 2D maths, the maths library. We'll copy this once. We'll do vec4f vector4, taking a vector4 dot vec, and we'll do copy. We'll do mat4f for our matrix. Const is going to take in a mat4 reference, call it mat. Okay, cool. It's going to take some more. We'll just code it. We'll just code these three first, and then we'll code later. Alright, so bind and bind, I'll do it right here. So shader uniform. Alright, so void shader set uniform vec3f. We've taken a let's copy and paste. I can't even bother typing these again. Copy paste. We'll do something like so first to set the shader uniform, first we need to find the location of the shader. We'll do int location GL get uniform location. So the program is going to be p underscore shader ID. I hope we're yep we're streaming. Awesome. P underscore shader ID. The name is the uni name. So if we cannot find the shader, so if the shader location is lesser than equal to -1, like cannot find uniform named name, call uni name. Okay, and if we cannot, we can just return from this function. But if we do, we're gonna set the actual uniform. So we'll do GL uniform vec GL uniform I think it's called there's nothing for vector. It's a 3FV, so it's a vector form. GL uniform 3FV. Send the location. It's the location of the uniform, so let's find the location. Count how many. We're sending 1 of the vector, and the value is going to be the address of vector, and that's pretty much it. Vector.x. Okay, cool. GL is supposed to be a B. That should be fine. We'll copy this again. Location, so it should be uniform vec4f. For vec should be this location. We'll do major uniform 4fv. We'll do vec.x. Okay, cool. That's it. Let's do one for our matrix. F mat4 location, you need name. We'll do for some reason it's a vec. We'll have to do mat here. So here, so for matrix we have separate name. We have GL uniform mat4 or uniform matrix 4FV. So the location is going to be our location. Count how many matrices we're sending. 1 matrix. Now transpose. Now I touched into this transpose thing in my previous matrix episode. Basically the way we're making we had made our mathematics library is we have the matrices all in the column major. No, not the column. Our matrices are in the row major, but OpenGL expects them to be in a column major, so we'll have to transpose it here. So we'll do GL underscore true. So we want to transpose our matrix. The value to the beginning, the first float, is just mat I will do 0 0 and basically the address to it. That's basically it. And of course this might not work because okay, it works. Nice. Okay, it does not. So mat 404. Okay, cool. That's pretty much it. It's pretty much our matrix. Okay, I also want to do some more again for the for other floats, for other like normal float or normal stuff there and stuff like those. So yeah, I'll do one for void set uniform int for just one integer. You can set for one int. You set uniform int was like one int, I guess. Int one. I can just call name const char uniname. A reference to an int. I'll just make the function here. So void set uniform at 4fp. So void shader set uniform int one. Name will do const reference to an int data. I'm literally just gonna copy and paste this. I don't even care. Get uniform name. We'll do GL uniform one I. Yep, so one I. So location is gonna be location. Int is gonna be data. That's it. That's pretty much it. Okay. Okay, one I. This is pretty much it. One IV as well. I wanna store an array of ints. So one int int one V. Yep, this is int is set uniform int 1v. So for 1v for vector. Yep, that's pretty much it. I'll just go here. I'll literally copy and paste this again. Int 1v, and this is gonna take a pointer to a data. I can just have it take a pointer to a data, a constant. Const. I don't want to change the data. Neither the data nor the actual pointer. On V, I'll call this, send it GL uniform one IV, I believe. Yep, one IV. Location. So sending the location, of course. The data is sending one. Value is copied from the data. That's it. So yeah, that's basically it. Alright, so one IV is done. That thing is done. That's pretty much it. So vector 3, vector 4, 2 floats. If I want to send 2 floats, I can just do that. Probably make one for float as well. Yep, I'll just make one for float as well. So copy this. Uniform flow 1. This is just a single float. Const float data. I'll do void shader set uniform flow 1 const char pointer uni name reference to a float. Copy this again, paste it here, and we'll do geo uniform f1f f11f. Okay, so location is location. The float is for the data. That's pretty much it. Okay, flow 1, float 2. So we don't need for 2 floats. I can just do for a vector. I can do for a like a 2-component vector. So set uniform. Let's copy this. So copy it here. Vector 2f, so taking a vector 2 by reference. Of course we don't have that yet because we have to include maths vector vector2.h shader here, vector2 right vec. Yep, it works. Copy this, I'll go here, do it in the first, I'll just do it right over here. Here, shader, copy this again, geo uniform, float 2f, so 2f is gonna expect us to like give the actual float. We can do that if you want to, like we can do vec.x, vec.y, since our vectors are stored in a contiguous form, we can just do geo uniform 1fv fv 1fv vectors, so the location 1, the value is going to be address of vec.x. Okay, cool. That's pretty much it. Of course, if we want more, we can set the uniform as we need it. For now, it's more than enough as you need it. Okay, cool. So we do one uniform. I can just change the names. I don't like the name. I can do set uniform 1i. Yep, I like it as I like these names. 1iv, 1fv. I just like these names much better. C1i, error entire. Let's call it 1i, 1iv, because I didn't like the name before. That's why. 1f. Should be 1f. Yep, cool. 1f. Okay, so one flow. That's pretty much it actually. Should be enough. So one matrix, so vector 2, vector 3, vector 4, matrix 4, one integer arrays, and one flow. Okay, cool. Should we do a one integer? Yeah, we can do if you want. Yeah, we can do a float array as well. Why not? We copy this. We probably don't need the float array as much as we need the integer array, but we can do that. It's not a big deal. So const float, const data, this 1fv for the float, const float, const data, const 1fv location. We are sending 1, copy it from the data. That's pretty much it. So yeah, that should be more than enough for our shader code. Yep, that's pretty much it. That's our shader class. We can of course add more if you want. Like if we need uniforms, if we are doing our project, we'll just keep adding them as we need them. But for now, it's just these are the bare minimum that we need to get something. Okay, so cool. Should be enough. Let's go to main.cpp. We include a shader, save it, bind. Let's see if we still get our thing in there. We do. Let me get rid of this. Now let's just check our uniform. Let's just check our uniform per one. So let's make our triangle a bit smaller. Okay, let's make it half the size right now. So now we can just check both our matrix class and also our shader class. Okay, so in the vertex shader, I'm gonna put in a uniform It's gonna be a mat4. By the way, these mat4, they are independent from our own class mat4. They are OpenGL's own mat4. So these are different. Okay, these and these are different. These are OpenGL's own. These are something that we made to give it to OpenGL. Okay, so uniform mat4, call u_model. So model matrix basically. I'll do multiply by u_model, and the matrix we'll set it here. So we'll do shader. So after we bind it, so remember to set the uniform after we bind it. Okay, so do shader dot set uniform mat4f. We'll obviously have to make a matrix for the scale. I'll just get rid of these now. We don't need to test our mats. Let me make the matrix first. So scale, and I'll go mat4 sc for scales. Do a scaling matrix scale, and I'll do something like takes in a vector tree. So I'll just scale it half in the x, half in the y. Don't touch the z because we don't care. So the mat4, it wants the name of the uniform, so it's u_model, and it wants a reference, a constant reference to a mat4. So we'll just send sc right here. Okay, cool. That's pretty much it. If we run the code now, hopefully, because we actually transpose the matrix, I believe. Yep, we transpose it. We do everything we need. Transpose it here. Hopefully, we'll see this stuff half of the size, and we do. Look how awesome that is. We see our stuff half the size. That's pretty awesome. If you wanted to check like the if we wanted to check the matrix multiplication, we can just do like mat4 model. So to make a mat4 for model be a matrix here, it'll be a identity matrix. Do mat4 can do so. We can do translate. We can translate as well. So do translate. Let's translate it to a. Let's translate it 0.5 in the x, 0.5 on the y, and don't touch the z. Okay, and here we can just model. We can do model equals to. We'll have to do scale first, so we'll have to translate times scale. Times scale. Okay, cool. Not scale, it should be sc, and yep, that should be model. We'll send the model. So scale and transit. So the matrix order goes from right to left. So here's our vertex. So here will be our vertex. So vertex in our shader, because we have this like this. So here's our vertex and here's our model matrix. So we go from right to left. So first we hit it with the scale and the translate, because the order should be first we do scale, rotate, and then we do translate. Okay, awesome. Check it. Let's hope our triangle is in a different position, and it is in a different position, and it's all looking fine. And if we even want to get more quirky, we can do rotate as well. So rot, awesome name. Rotate, we want to rotate at the angle, so 2 radians. So we want to rotate 30 degrees. We want it to rotate in the z direction, so we can actually see the rotation happening. Okay, cool. Do more multiply here, rot, multiply. We'll run the code, and it works beautifully. Awesome. You can see our weird little triangle. It works well, basically. That's what I'm trying to say. Okay. Cool. That's pretty much it. And if you wanted to do real fun stuff, we could actually do something like this. What we can do is, I guess we can, yeah. So what I'll do, I'll get rid of the translate. I'll copy this here. I'll paste it here. I'll get rid of the translate, of course. Here I'll make a new rotation matrix every single time we do it. So mat4 rot. I'll copy this rot, make an identity matrix. You don't really have to do this, but still do it for good programming practice. 2 radians. We'll do something like GLW get time, which is probably going to be a bit less. We'll multiply it by something like 5. In the Z direction, we're going to rotate, and it's going to give us a new matrix every single time, and we set the model matrix every single frame. So if we do it now, see a rotating triangle, and of course we need to increase the let's do something like 20. Okay, cool. See, we see an awesome rotation. Now it's rotating in the G direction because the Z should be going in, the positive Z is going inside, like the positive Z is going outside your screen to you, so it's gonna rotate from left to right. So if you want to rotate it to right, we'll just have to negate it right here. Okay, let's do this, and bam, there we go. There we have a rotating triangle. Now I want to increase the speed as well. I'll increase something like 50, and boom. Isn't that cool? Yeah, that's pretty awesome. Yeah, that's basically it. That's actually awesome. So this episode we did quite some stuff. We actually changed the color, we changed the position, we rotated it, and this was a really fun episode. Now since we have done our shader class, now we can do a lot of cool stuff with it. Yeah, it's just, yeah, we're just gonna get into it real quick. We're gonna get into some fun stuff real quick. Next episode we're gonna be getting into shaders. Not shaders. We're gonna be getting into textures. This is gonna be really fun as well. And after that, we're gonna be getting into something like, we're probably gonna get into a camera system, and then we're gonna be getting into batch rendering. Oh my god, it's gonna be fun. So some more episodes are coming. Okay, let's take a look at this beauty again, just so I can look at it for a lot of time. Yeah, that's pretty much it, guys. Thanks for watching. I'll see you guys in